syntax and LF, are these inherently tied together, or is there room for the other representations like local nameless and stuff to interact with these?
They're not necessarily inherently tied together. I mean, I think it makes perfect sense. Any proof state you work with in Pop, whatever object encoding you choose, is for me a contextual type. But I think, okay, that, so high order abstract syntax for me is not just an encoding technique to reason about formal systems. It is actually something that very naturally comes up if you want to have an abstract way of, for example, adding pattern matching to a system that does code generation. I don't have time to do that today. I wanted to do something very different on Saturday. But I think there's sort of lessons we can learn in general about how we should think of programs and really analyze them. And the reason is, imagine I have generated some code. Okay, that looks like this. Plus 0. And I would like to get rid of this pesky 0 because, I would like to simplify this. I would like to simplify this to x plus x. And even if you say I have a function, okay, even if you say I don't know what function, maybe I just have a function. Okay, but I still would like to transform this function into something that says box fn x plus x. How am I going to do that? Am I asking, okay, the current state is that we use some kind of term representation that exposes the Green indices. Okay, so if you look, for example, at the encoding of template Haskell or meta-talk, okay, what it's doing is it says, oh, what you really wrote here is not this X. You wrote some kind of degree, meaning the same thing. As soon as you want to manipulate the syntax of this term, you get some kind of degree representation of this term. And you need to deal with these degree representations. They're not even well scoped. Meta-talk gives you some term representation. It's not a well scoped degree representation. So you have to be careful. Maybe all of you are careful. But there's a reason, I think, right, why we like typed languages, and to help us sort of be careful, okay? To somehow watch over us what we're doing. And, I think, I forgot one of the speakers, maybe Valeria, also said, I kind of think it's a brilliant disease. Who has programmed with the brilliant disease? Who has, programmed literally, a type checker or something more interesting with the brilliant disease? Who has encountered wrong indices? This happens to everyone. And it's really annoying. It's I passionately hated the brilliant indices. So what I would like to do is, I would like to analyze this program. And maybe it's parentheses like this, I would like to say, okay, these expressions are built out of axes, and then there's some other expression, and I can continue to analyze that expression until I find the 0. But then I need to talk about the Zax, I need to have a pattern variable essentially that will represent this expression that I can make a recursive call on. But again, this is not a closed term. This is containing X.
To be clear, you're talking about manipulating as syntax.
I'm not talking about manipulating as syntax, but that is what we're doing when we're writing compilers or when we're implementing languages. And if you really want to empower programmers to write their own code transformations, because maybe they know something about the code they've generated, for example, that it is of this form and they want to get rid of this plus 0. So simplifiers, we write simplifiers in tactics and quite often. Then, well, if I want to not work with the Brilliant indices, which is for me like working with assembly, then I need some names, okay? And I want to use names sort of hygienically or safely. And that means that what I have given and what my recursive call is something that contains X. Now, obviously, the name X doesn't really matter. It could be X prime, could be Y, it could be common H. But it is some name. And that means that this guy would also be, if I do pattern matching, this would also be a contextual type. So maybe to wrap up, right? So we, for example, extended the system to system F, so we can actually generate code generation for polymorphic code, okay? And do pattern matching on these kinds of structures. And when you read this paper, it doesn't explicitly say higher order system type, but it's very much infused by how we think about terms in higher order system type. And that was a paper at Poplar in 2022. And we also extended this to Martin-Lewis type theory. Okay, so this does scale. Okay, so we had a paper in Poplar 2025 where we describe essentially an extension of the system to Martin-Lewis type theory together with pattern matching on this kind of structure. But I think there's a lot more that can be done. So you can also think about like what is sitting inside the box. So here it's homogeneous. Okay. So you could say, well, does it need to be homogeneous, or can I do heterogeneous programming? And so one of my students, paper at ICP this year, where essentially what is inside the box is actually process calculus, where you can write concurrent computations, and it sort of combines, therefore, through the box, it combines the concurrent computation, which is inside the box, with functional programming. And the functional program in language has the ability to manipulate and transform processes, if you like. If you want to optimize processes, then you can do that. So these are all examples, essentially, where we can use this idea in many ways. And in Beluga, it's also heterogeneous. Essentially, what is sitting inside the box is you have a functional layer, and what sits inside the box is essentially an encoding of whatever kernel system you're working with. And the last thing I want to say, okay, so this is not the only way you can formulate a system for the box modality, with box and let box. But you might say, well, really what I'm used to for meta-programming is that I have quote and splice. Well, just quote and splice, or quote and unquote. And this isn't really quote and splice. And you might say, well, yeah, okay, but this isn't quote and splice. And you're right, but one more, give me 2 more minutes. Okay. But if you wanted to have quote and splice, there's an alternative formulation, which is closer to the crypto world. Where we essentially have a context stack of these contexts, okay, rather than separating out the assumptions that live forever and the assumptions that are available currently. And this is essentially modeling what assumptions are true at every stage or at every world. And then you can have 2 rules, essentially the box rule that will say box A will type box A, and you step to the other world. And then you have an unbox rule that is maybe more what you guys wanted to begin with. Okay. You can step to the prior world. Okay, so unbox. If you had something that was true previously, you can import it. So this was true at some prior world, but since it's true forever, you can also know it's true in my now world then. Now I'm mentioning this because Frank and Rowan showed back around 2000 that these two systems can be translated into each other. And B, there's a lot of work on modal type theories that uses this kind of formulation. They don't use a semicolon, they use something called a lock. Okay? The semicolon is like a lock. And they sometimes call it Fitch-style modal type systems, which personally I think Kripke-style is more accurate. But this is an alternative formulation. But if you use locks, you don't get these nice structural properties about these kind of complex stacks. So you have a lot of side conditions that ensure that what you're working with are sort of good structures. But I wanted to mention that this is not the only thing. And in fact, this would be sort of more akin to quote, and this would be more akin to splice. But it is actually equivalent to the system. But this system here is somewhat nicer behaved. It has a nicer, simpler meta theory. Okay, so this brings me to the end of today. Okay. What I want to do on Saturday, hopefully, I still take requests. But my plan for Saturday was to talk about linear and adjoint logic. But if you have other requests, tell me. And we'll see. Okay, I'll see you later.
Okay, so just to point out, the schedule has changed an awful